Okay, so today I'm going to find the value of pi using the Archimedes function. Okay, so let's get started. So first of all, I will want to show you something in the GeoGebra application. Okay, here. So here I got a circle with a polygon inscribed in it, and here let me zoom it. So there are some side, 1 2 3 4 5 6 7 8 9. 9 is a 9-sided polygon, and if I increase the number of sides, then the perimeter of the polygon will start approaching the perimeter of the circle. So here that how we can do it. So this is the the line segment HB. HB is the side of the original polygon, and here I have many small sides. So this is a side L, I L, then M, Q, then I start, then I have OR, and so on. So as the number of sides increase, the perimeter is starting to approach the perimeter of the circle. Over here there is still some gap, there is still some space left, which can be fulfilled by adding another segment, which is UV. And here, let me delete it. Okay, and here we got some space more. See, it's getting broader and broader, which means there is a tiny space left. So in this way it is approaching the perimeter of the circle. So what if we somehow manage to make the value of the perimeter equal to pi? Nice, right? So here how we can do it. So here I took a circle having the radius of half units. So here, as you know, c is equal to 2 pi r, which implies c is equal to 2 times pi into half, where 2 divided by 2 is equal to 1, where pi into 1 is equal to pi. So there you got the circumference equal to pi. So here is a similar circle which has a polygon inside it. Let's imagine it to have many sides. So as we got many sides, we have some. So the thing that I did is I drew a perpendicular bisector from the center to the point B over here. You can see this one. So after doing that, it gets divided into two parts, and I named those two parts x, and other side should also be equal to x, which is x. So in this way I got two sides. So we know that this parameter approaches the perimeter of the circle. So let's first find out this parameter of the polygon. So to find the length of this side, we have to use some trigonometry. So let's call this angle as theta. So as you know, sine of any angle is equal to the perpendicular by the hypotenuse, where the perpendicular here is this x side, and the hypotenuse is this side. So in this way we got the things. So here the perpendicular is equal to x, right? Perpendicular is equal to x, and the hypotenuse is equal to half. Let me show you how does it work, because the radius is half. right? That is why the hypotenuse is also half. Okay, so let's start something. So here let's write the thing that we got here. So sine of theta is equal to x into half, x by half, sorry, which implies that sine theta is equal to 2x. This means x into 2. So in this way we got 2x. Sine of theta is equal to now 2x. So as we know that 2 times x is equal to this side, right? So that is why one side. Okay, so we got sine of theta is equal to s, which is side. So now let's see what's next. So we got that the parameter is equal to n times side. Let's say you have a triangle, and equilateral triangle, and each side measures 1 centimeter, and that is why the parameter should be 3 into 1, which is equal to 3. Just like that. It's just like that. So here the s is equal to sine of theta, which is equal to n into sine of theta. So let's figure out the value of theta, right? So this is a way to figure out the value of theta. So that this whole thing is 360 degree, right? So if we divide 360 degree by the number of sides, then we will get this angle. Wait, let me show. Wait, this angle, right? This angle. So and if we divide it by 2, then we will get theta, right? Okay, so we've got it. So here 360 degree by the number of sides into half is equal to 180 degree by n. Okay, we got it. So in this way the sine of theta equals to 180 degree by n. Sorry, sine theta only equals to 180 degree by n. We got this. So in this way we got a function. So let's study this function here. So here I have that function written in bold letters. So let's see, the parameter is equal to n times sine of 180 degree by n. So let's see what happens. So here when n starts approaching infinity, right? So the number of sides, as I have shown here that as I had shown you here that as we increase the number of side, the perimeter of the polygon will also start approaching the perimeter of the circle. So the same thing is happening here. So as we increase the number of sides, and the number of sides starts approaching infinity, this value means this value will start approaching the value of pi, as this value is nothing but the perimeter of the circle, which is equal to pi, right? So in this way we got a function where if we increase the value of n to infinity, then we can figure out the value of pi.